There's one place in the oceans that has particularly sinister fame. In the distant 15th century, Christopher Columbus's expedition faced something that made the whole team panic. The Great Discovery Ship Journal contains accounts of the compass needle going haywire. The sea has an odd glow to it. Many years later, this dead place proved once again how sinister it is. Ships disappear without a trace here. Sometimes they are found, drifting, empty, and completely desolate. But it's not only ships that go missing, planes disappear too. The facts and rumors about this incredible phenomenon have quickly spread around the globe. And soon, this region of the Atlantic became known as something sinister. And it continues to uphold its eerie reputation, even today. You've already guessed it. This is the Bermuda Triangle. What kind of supernatural power is hidden under its waters? And what does science say about all this? The Bermuda Triangle. For starters, let's review the most notable incidents that brought the Bermuda Triangle its loud and sad fame. On January 31, 1880, the training sailing ship HMS Atalanta sailed from the Royal Navy dockyard in Bermuda to Falmouth, England. The ship didn't reach the British Isles, it hadn't even left Bermuda, it simply disappeared without a trace. It was assumed that the ship sank after encountering a severe storm on its route, and that the crew wasn't experienced enough to handle the situation. At that time, the whole world was eager to learn about the ship's fate. When the ship went missing, the Admiralty received over 150 telegrams and 200 personal calls from concerned friends and relatives. The missing ship made headlines, and the public demanded an explanation. People came up with all kinds of plausible theories. But neither the wreckage nor the bodies of the dead, let alone survivors, were found. HMS Atlanta's disappearance has remained a mystery. The coal carrier Cyclops, loaded with manganese ore, left the island of Barbados on March 4, 1918. A few days later, it vanished without a trace, along with its 309-person crew, resulting in the highest number of non-battle casualties in U.S. Navy history. There are many hypotheses regarding the loss of the U.S. Cyclops. Some people blame a strong storm, others blame the overload and the structural damage caused by cargo. And others even suggest an attack by the Imperial German Navy. But the fact remains that the ship disappeared without a trace in the ocean area. That later became known as the Bermuda Triangle. And now that you've learned all about it, let's just start from the very seabed. The bottom configuration in this ocean region is well studied. It's even known what lies several kilometers under the seabed in the Bahamas and Bermuda region. A lot of drilling and geophysical research was performed. There is also an amazing variety of seabed landforms in the Bermuda Triangle, which is hardly found anywhere else on the planet. There is a shelf with shallow banks, a continental slope, marginal and median plateaus, deep straits, abyssal plains, and deep-sea trenches. This wide variety is very rare to come by in such a relatively small ocean area. Scientists conducted a planimetry of a large-scale morphological map of the seabed and established that the Bermuda Triangle area can be arbitrarily divided into two parts: the southern and northern ones. The southern one includes the Florida Shelf, the Bahamas Banks, the Straits of Florida, and the Puerto Rico Deep-Sea Trench. In this part, the seabed shape looks very striated, extensive shoals alternate with straits and great ocean depths. The northern part of the triangle is more calm and has a relatively uniform bottom topography. The wide shelf turns into a spacious deep water plain in its north and east, where some seamounts and a rather large Bermuda Plateau arise. Now this is where it gets interesting. In fact, a mountain is too strong a word, but there are several groups of seamounts in the northern and eastern parts of the triangle. Some of them even have names, but most remain unnamed. The fact is that they are only 150 to 200 meters high by surface standards. These are not even mountains but hills, but for the seabed, these are quite remarkable formations. These small mountains in the area have a rather peculiar, almost regular conical shape. Lower cones of less than 100 meters are more numerous, and these are actually called underwater hills. When viewed from above, the mountains have a round or elliptical shape. The slopes of 10 to 30 degrees aren't too steep, and the foot can range from several kilometers to several tens of kilometers in diameter. Seamounts and even slopes in this area have a regular shape, which is sometimes complicated by several terraced steps. The original material that formed the seamounts is basalt, but it's hard to see because the mountains are covered with limestone deposits. The limestone platform that forms the bottom of the Bermuda Triangle is a unique geological formation. The limestone deposits here are almost 6 kilometers deep, and all this thick layer is the remains of ancient small creatures. For hundreds of millions of years, the natural conditions that we see today have remained virtually unchanged. They can also be found in subduction zones, where one plate sinks beneath another. Alternatively, volcanoes emerge as a result of persistent vertical magma flows that rise from the mantle depths and gradually melt the lithospheric plate above, giving rise to the Hawaiian Islands that continue to form even today. When geologists conducted an additional analysis of an 800-meter core from Bermuda in 1972, they discovered a very unusual mineral composition, as well as lead isotopes, and some other heavy elements, which led to several hypotheses about Bermuda's origin. According to the most plausible theory, the disruptions in magma flows lifted and mixed the matter fragments of ancient plates preserved in the mantle transition zone. This may seem unclear, but once you understand all this, you'll be surprised. Let's remember that the entire Atlantic Ocean emerged about 175 million years ago. As a result of the split of the Pangaea supercontinent, which previously contained almost all of the planet's land. The plates that today form Africa, Europe, and the Americas parted, giving rise to an ocean between them. Numerous plate fragments plunged into the mantle under the ocean bed, sinking into the transition zone at a depth of about 400 to 600 kilometers. About 30 million years ago, mantle flow disturbances made several of these semi-molten debris float higher while merging, mixing, and interacting with water. Such a process could create not only Bermuda, with its unusual geology, but also some other volcanic islands in the oceans. The Bermuda Triangle was an unusual place tens of millions of years before it became mainstream, but what rises above the water in the Bermuda Triangle has its opposite, which is even more interesting. There is nothing but the Puerto Rico Trench. The deepest point in the Atlantic Ocean, the Milwaukee Deep, lies in the Bermuda Triangle. Science fiction writers often imagine that the deepest parts of the ocean hide mysterious forces and unknown creatures. The Puerto Rico Trench appears to inspire such thoughts. But there's nothing mysterious or supernatural at its bottom. Perhaps we'll find something interesting in its very thickness. At first glance, the structure of the triangle bottom seems unremarkable. Here, one can mostly find regular sedimentary rocks such as limestone, sandstones, and clay. This layer's thickness ranges from 1 to 2 kilometers in the Bermuda Plateau area, and up to 5 to 6 kilometers near the Bahamas banks. The average rate of sediment accumulation is approximately 6 millimeters per 150 years. But this is only at first glance. There's something in this area that haunts not only mystery seekers, but also quite famous researchers who are concerned about safe seafaring. We are literally talking about a time bomb. A real gas bomb. We know almost nothing about where and when it will explode. Now this is where it gets really interesting in the hopes of explaining some of the strange ship disappearances. Therefore, there aren't so many bold theories. Scientists and enthusiasts are desperately trying to find a balance between bold hypotheses and a rigorous scientific approach that rules out hoaxes. One of them concerns eruptions of methane hydrate deposits, a special form of natural gas. For example, the presence of large deposits of methane hydrates on the continental shelves has been scientifically proven. The only question is whether the rapidly released masses of these substances can sink a ship. Some very serious experiments were performed to find that out. For example, a group of Australian researchers conducted a series of simulations. The results were actually promising. When experimenting with smaller ship models, the models sank quite easily. This was due to a sharp decrease in the water density. It has been suggested that intermittent methane interruptions may create areas of foamy water that can't provide sufficient buoyancy for ships. Such an area formed around the ship could cause it to sink very quickly and unexpectedly. Hence the lack of distress signals. They simply couldn't be sent in time. The debris would then be quickly swept away and scattered by the Gulf Stream. Furthermore, there exist a lot of well-founded explanations debunking the mysterious nature of even the most high-profile disappearances, but mysteries attract inquisitive minds. No matter how overrated the Bermuda Triangle is, no matter how far-fetched its secrets are, it inspires the curiosity of whole generations. And it's in the pursuit of mystery that humanity often discovers the true nature of phenomena that quickly turn from fantasies to indisputable facts.